Exercise 4.1. 1. Use the figure to name A. 5 points, B. A line, C. 4 rays, D. 5 line segments. 2. Name the line given in all possible, that is, 12 ways, choosing only 2 letters at a time from the 4 given. We have the 4 letters as A, B, C and D. Page 75. 3. Use the figure to name A. Line containing point E, B. Line passing through A, C. Line on which O lies, D. 2 pairs of intersecting lines. 4. How many lines can pass through A. 1 given point, B. 2 given points. 5. Draw a rough figure and label suitably in each of the following cases. A. Point P lies on AB. B. XY and PQ intersect at M. C. Line L contains E and F but not D. D. OP and OQ meet at O. Six. Consider the following figure of line MN. Say whether following statements are true or false in context of the given figure. A. Are points on the line MN. Q, M, O, N, P. B. M, O, N are points on a line segment MN. C. M and N are endpoints of line segment MN. D. O and N are endpoints of line segment OP. E. M is one of the endpoints of line segment QO. F. M is point on ray OP. G. Ray OP is different from ray QP. H. Ray OP is same as ray OM. I. Ray OM is not opposite to ray OP. J. O is not an initial point of OP. K. N is the initial point of NP and NM. (4.8) Curves. Have you ever taken a piece of paper and just doodled? The pictures that are results of your doodling are called curves. Figure 4.10 given here shows 7 different shapes. Page 76. You can draw some of these drawings without lifting the pencil from the paper and without the use of a ruler. These are all curves. Figure 4.10. Curve in everyday usage means not straight. In mathematics, a curve can be straight like the one shown in figure 4.10.4. Observe that the curves 3 and 7 in figure 4.10 cross themselves, whereas the curves 1, 2, 5 and 6 in figure 4.10 do not. If a curve does not cross itself, then it is called a simple curve. Draw 5 more simple curves and 5 curves that are not simple. Consider these now. Figure 4.11. We have 2 different curves. What is the difference between these two? The first, that is, figure 4.11.1 is an open curve, and the second, that is, figure 4.11.2 is a closed curve. Can you identify some closed and open curves from the figures 4.10.1, 2, 5, 6? Draw 5 curves each that are open and closed. Position in a figure. A court line in a tennis court divides it into 3 parts. Inside the line, on the line, and outside the line. You cannot enter inside without crossing the line. A compound wall separates your house from the road. You talk about inside the compound, on the boundary of the compound, and outside the compound. In a closed curve, thus, there are 3 parts. 1. Interior, that is, inside of the curve. 2. Boundary, that is, on of the curve, and 3. Exterior, that is, outside of the curve. In the figure 4.12 given here, A is in the interior, C is in the exterior, and B is on the curve. The interior of a curve together with its boundary is called its region. 4.9. Polygons. Look at these figures 4.13. One, two, three, 4, 5, and 6. Page 77. What can you say? Are they closed? How does each one of them differ from the other? 1, 2, 3, 4, and 6 are special because they are made up entirely of line segments. Out of these, one, 2, 3, and 4 are also simple closed curves. They are called polygons. So, a figure is a polygon if it is a simple closed figure made up entirely of line segments. Draw 10 differently shaped polygons. Do this. Try to form a polygon with 1. 5 matchsticks. 2. 4 matchsticks. 3. 3 matchsticks. 4. 2 matchsticks. In which case, was it not possible? Why? Sides vertices and diagonals. Examine the figure given here. Figure 4.14. Give justification to call it a polygon. The line segments forming a polygon are called its sides. What are the sides of polygon ABCDE? Note how the corners are named in order. Sides are AB, BC, CD, DE, and EA. The meeting point of a pair of sides is called its vertex. Sides AE and ED meet at E, so E is a vertex of the polygon ABCDE. Points B and C are its other vertices. Can you name the sides that meet at these points? Can you name the other vertices of the above polygon ABCDE? Any two sides with a common endpoint are called the adjacent sides of the polygon. Are the sides AB and BC adjacent? How about AE and DC? The endpoints of the same side of a polygon are called the adjacent vertices. Vertices E and D are adjacent, whereas vertices A and D are not adjacent vertices. Do you see why? Consider the pairs of vertices which are not adjacent. The joins of these vertices are called the diagonals of the polygon. In the figure 4.15, AC, AD, BD, BE and CE are diagonals. Is BC a diagonal? Why? Or why not? Page 78. If you try to join adjacent vertices, will the result be a diagonal? Name all the sides. Adjacent sides, adjacent vertices of the figure ABCDE. Figure 4.15. Draw a polygon ABCDEFGH and name all the sides, adjacent sides, and vertices as well as the diagonals of the polygon. Exercise 4.2. 1. Classify the following curves as 1. Open or 2. Closed. We have 5 different types of curves: A, B, C, D, E. 2. Draw rough diagrams to illustrate the following: A. Open curve. B. Closed curve. 3. Draw any polygon and shade its interior. 4. Consider the given figure and answer the questions. A. Is it a curve? B. Is it closed? 5. Illustrate, if possible, each one of the following with a rough diagram. A. A closed curve that is not a polygon. B. An open curve made up entirely of line segments. C. A polygon with two sides. (4.10) Angles. Angles are made when corners are formed. Here is a picture. Figure 4.16, where the top of a box is like a hinged lid. The edges AD of the box and AP of the door can be imagined as two rays, AD and AP. These two rays have a common initial point A. The two rays here together are said to form an angle. An angle is made up of two rays starting from a common initial point. The two rays forming the angle are called the arms or sides of the angle. The common initial point is the vertex of the angle. This is an angle formed by rays OP and OQ. Figure 4.17. To show this, we use a small curve at the vertex. See figure 4.17. O is the vertex. What are the sides? Are they not OP and OQ? How can we name this angle? We can simply say that it is an angle at O. To be more specific, we identify some 2 points, one on each side, and the vertex to name the angle. Angle POQ is thus a better way of naming the angle. We denote this by sign of the angle POQ. Think, discuss and write. Look at the diagram, figure 4.18. What is the name of the angle? Shall we say angle P? But then which one do we mean? By angle P, what do we mean? Is naming an angle by vertex helpful here? Why not? By angle P, we may mean angle APB or angle CPB or even angle APC. We need more information. Note that in specifying the angle, the vertex is always written as the middle letter. Do this. Take any angle, say angle ABC. Shade that portion of the paper bordering BA and where BC lies. We have two figures demonstrating this. Page 80. Now, shade in a different color the portion of the paper bordering BC where BA lies. The portion common to both shadings is called the interior of angle ABC. Figure 4.19. Note that the interior is not a restricted area. It extends indefinitely, since the two sides extend indefinitely. In this diagram, figure 4.20, X is in the interior of the angle. Z is not in the interior but in the exterior of the angle, and S is on the angle PQR. Thus, the angle also has three parts associated with it. Exercise 4.3. 1. Name the angles in the given figure. 2. In the given diagram, name the point or points. A. In the interior of angle DOE. B. In the exterior of angle EOF. C. On angle EOF. Three. Draw rough diagrams of two angles such that they have A. One point in common. B. 2 points in common. C. 3 points in common. D. 4 points in common. E. 1 ray in common.